This new example differs significantly from the previous one. First, we consider the design of a dual-band notch filter, which is itself a more complex problem. Furthermore, the target requirements are formulated not for normal incidence, but for an incidence angle of 30 degrees. These requirements are formulated simultaneously for both S and P polarized light. In the file, Project menu of OptiLayer, open the directory Lec25D26-2. Load into RAM the data files needed to run this exercise. These are the substrate glass N equals 1.52, the layer materials SiO2 and Tia2O5, the composite material composition material SiO2- Tia2O5, the target file 2-line NF for 30-degree light incidence, and the staring design Rugate starting layer 10,000 nanometers. Before starting the design mode, it is recommended to check the contents of the loaded data files using the edit command in database windows. The substrate, layer materials, and composite material are the same as in the project Lec25D26-1. Go to the General Information window and check that the abbreviations L and H are assigned to the SiO2 and Ta2O5 materials, and the abbreviation A is assigned to the composition material SiO2- Ta2O5. The target data file 2-line NF 30-degree incidence defines two high reflection zones, 522 to 542 nanometers, and 628 to 648 nanometers. In the spectral range from 430 to 700 nanometers, excluding these zones in the 5-nanometer wide transition zones between high and low reflectance, high transmittance is required. The design Rugate starting layer 10,000 nanometers is a Rugate layer with a physical thickness of 10,000 nanometers. To begin designing of the Rugate notch filter, select the Rugate Synthesis option of the Synthesis menu. Using the Options button at the bottom of the window, ensure that the refinement method is set to the quasi-Newton DLS. Click the Start button to proceed to the selection of the refinement mode, which will be available in the window that opens. Select the default parametrization mode. In the next line, rugate-type, select the multi-apodized sign. The selected analytical formula of the Rugate layer is displayed in the sub-window below this line. In the Parameters field, change the default number of slices to 500. In the Number of tones field specifies the number of reflection zones of the notch filter. Enter 2 here. As a reminder, in the following lines, the parameters that can be modified are marked in gray in the value column. In the line alpha 0, set the mean value of the refractive index of the Rugate layer, value, its lower, Shari min, and upper, max limits to 0.5. As before, the main parameters to work with are delta alpha and lambda/th. Since we now have two target reflection zones, the spectral properties of the design filter are determined by two pairs of these parameters. Accordingly, 2 rows will be used to set the initial values and boundaries for the parameters delta alpha and lambda/th. We will leave all the default parameters in the delta alpha rows and move on to selecting the parameters in the lambda/th rows. By changing the values in the value column, we find 2 suitable lambda/th values, 0.0155 and 0.0186, which reduce the MF from the initial value of 38.21 to 21.02. Clicking the Run button starts optimization of the parameters of the selected analytical formula. After approximately 2 minutes, the MF is reduced to 17.80. To further improve the spectral characteristics of the Rugate filter, let us refine the refractive index profile in tabular form. Click the Start button again and select Table Mode in the Refinement Mode field. The refractive index profile will be automatically converted into a tabular representation with the same number of slices that was specified in analytical mode. Move the refractive index smoothness slider one step to the right. This will increase the smoothness requirements to the Rugate profile. Click the Run button to begin the refinement procedure. Do not wait for it to stop. Instead, click the Stop button when the MF value is close to 5.24. Note that the spectral characteristics in the left part of the window are already significantly better than before starting the tabular refinement. Click the Start button again and move the slider one step to the left, returning it to its original position. Click the Run button. Soon the MF value will drop below 4.0. Click the Stop button. We can further reduce the smoothness requirements, but as in the previous example, we will increase the number of Rugate layer slices. Click the Start button. In the Number of Slices field, change 500 to 1000 and click the Run button again. Lower MF values will be reached soon. We have already achieved very good match of the target spectral characteristics. It is possible to continue to work with the control operations described to achieve low MF values and smooth Rugate refractive index profiles. Once you have a satisfactory Rugate design, you can save it to the design database by clicking Save button at the bottom of the starting window. Or by loading it to the general information in T&R and phase windows, and then saving it using the Save Data option in the data menu. The design database contains several designs of dual band notch filters with good spectral characteristics.